Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the different timer modes used in 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the programming for time delays. Okay, first of all, the calculating time delays with C. There are two ways to create a time delay in 8051 microcontroller. These are using simple for loop and using the 8051 timer. By using simple for loop, we cannot make or cannot obtain a precise time delay. To obtain the precise time delay, we have to use the 8051 timers T0 and T1. The delay length depends upon the three factors: the crystal frequency, the number of clock per machine cycle, and the compiler cycle. The crystal frequency, the duration of clock period for the machine cycle, is the function of clock frequency. Okay, that means the time delay is depends on the crystal frequency which is used in the 8051 microcontroller architecture. Then the next factor is the number of clock per machine cycle. The 8051 uses 1 divided by 12 of crystal oscillator frequency as one machine cycle. That is, each machine cycle is equal to 12 clock periods of the crystal frequency. Remember here that the 8051 uses 1 divided by 12 of the crystal oscillator frequency. That means if we have the crystal of 12 megahertz, then it is divided by 12 or it is multiplied by 1 divided by 12. Okay. Then the third one is compiler cycle. The compiler cycle affects the time delay. In C program, the C statement and the functions are converted into assembly language program by the C compiler. These are the three factors affecting for the time delays. Let's see the concept here. The programming the timer in mode 1 and mode 2. We know that we can select the modes of the timer by using the mode select bits M1 and M0 from the T mode register. By giving proper combination, we can select our desired mode. That means if both having value 0, then timer mode 0 is selected. If M has the value 0 and M0 has the value 1, then timer mode 1 is selected. If M1 has the value 1 and M0 has the value 0, then timer mode 2 is selected, and if both having value 1 1, then mode 3 is selected. Now in this topic we are going to see the programming the timer in only mode 1 and mode 2. Okay, let's see the steps to program the timer in mode 1 and mode 2. The steps are: first one is load the T mode register. Second is load the TL and TH registers with initial clock values. Third one is start the timer. Fourth one is observe the timer flag TF and exit from the loop when the TF flag is set. Fifth one is stop the timer. Sixth one is clear the timer for next round. And seventh is go back to step second, load the TL and TH registers. That means here the first is load the T mode register. In this step we specify the timer mode. That means the timer is used in mode 1 or mode 2. Okay, for that purpose we have to provide the value for the T mode register. Now the second step is load the TL and TH registers. By loading the TL and TH registers, we can obtain the time delay. Okay, hence for the time delay we have to load TL and TH register. After loading the values in TL and TH, then we are going to start the timer by setting the bit TR1 or TR0. If we want to start the timer 1, then we have to set TR1. If we want to timer 0, then we have to set TR0. Okay, then the timer starts. After timer starts, then we have to observe the timer flag. Okay, that means if we have the start timer 1, then we have to set TR1 bit, and if the timer start, then monitor the TF1 flag. If TF1 flag overflows, then that means the TF1 flag sets, then stop the timer. That means in this state make TR1 bit 0. Okay, then clear the timer for next round. Then go back to step second. I hope you all understand the steps used for the programming in the timer mode 1 and timer mode 2. Let's see some important questions here. How to load the values in T-mode register for selection of various timer mode. Here we are going to see only for timer mode 1 and for timer mode 2. This is the T-mode register. We know that T-mode is an 8-bit register M0, M1, C oblique T bar and gate. These lower bits are used for timer 0. The upper 4 bits are identical to the lower 4 bits and these bits are used for the timer 1. Okay, that means if we want to use the timer 0 in mode 1, that means we have to give the value 0 1 to the timer 0 and other bits are 0. That means we have to give the value 0 0 0 0, that means 0, and 0 0 0 1, that means 1 0 1 H. Okay, if we want timer 0 in mode 2, we know that we can select the mode 2 by using the combinations M1 equal to 1 and M0 equal to 0 and other bits are 0. Hence we get the combination here 0 0 0 0, that means 0, 0 0 1 0, that means 2. That means by giving the values 0 to H, we can set the timer 0 in mode 2. Okay. Now if we want to select the timer mode 1 of the timer 1, then we have to give combination of M1 M0 of the timer 1. We want it in mode 1, hence we have to give it combination 0 1. The other bits are 0. We get the combination here 0 0 0 1, that means 1, and 0 0 0 0, that means 0, that means 1 0 H. Okay, if we want the timer 1 in mode 2, then we have to give the combination M1 to M0 such that 1 0, other bits are 0, we get here 2 0. I hope you all understand how to select the proper timer in proper mode. Let's see once again. If we want to select timer 0 and mode 1, okay, consider here timer 0, hence the bits of the timer 1, that means these bits are having value 0 0 0 0. Okay, this gate and C oblique T bar has the value 0. We want to select mode 1, hence we have to give the combination M1 equal to 0 and M0 equal to 1, that means 0 0 0 0, this is 0 and this is 1, that means 0 1 combination. Okay, now if we want the timer 0 in mode 2, again we want timer 0, hence all the bits of timer 1 are 0. We want here mode 2, hence we have to give it combination 1 0, the other bits are 0, hence we get here 0 0 0 0, that means 1, and 0010 that means 2. Hence we get the combination for the T mode register is 0 to H. Okay. Then if we want the timer 1 in mode 1, now we want the timer 1, hence all the bits of timer 0 are 0. We want the timer 1 in mode 1, and we know that we can select mode 1 by giving the combination 0 1, the other bits are 0. Hence we get here 1 0. Okay. Now if we want to select timer 1 in mode 2, again we want to select timer 1, hence all the bits of timer 0 is 0. Mode 2 we can select by m1 equal to 1, m0 equal to 0, and the other bits are 0. Hence by giving the combination 20H we can select timer 1 in mode 2. I hope now you all understand how to select a proper timer and its mode. Okay. Now let's see the next question. How to load the values in TL and TH register for proper time delay. First of all, find the period for the given oscillator clock frequency. In each program or in each architecture of 8051 microcontroller, it has the crystal oscillator which oscillates at a certain frequency, which is known as the oscillator clock frequency. For example, if the crystal frequency is 11.0592 MHz, then we know that the frequency of the timer is 1/12 of the crystal frequency, that is, clock frequency f is equal to 1 divided by 12 into 11.0592. After solving this, we get 0.9216 megahertz. Okay. Here megahertz means 10 raised to 6 hertz. I hope you all know this. Now we get here the clock frequency f equal to 0.9216 megahertz, and we from this frequency we can find the clock period, that means t is equal to 1 upon f, that means 1 upon the 0.9216 megahertz means 10 raised to 6. Then after simplification this, we get here the clock period 1.0850 microsecond. Okay, that means if we have the clock frequency, the crystal frequency 11.0592 megahertz, then in this case we get the clock period as 1.085 microsecond. Here microsecond means 10 raised to minus 6 second. Okay, I hope you all understand this. Now let's consider again, if the crystal frequency is 12 megahertz, then we know that for the frequency for the timer is 1/12 of the crystal frequency, that is, clock frequency f is equal to 1 divided by 12 into 12, that means 1 megahertz. This is the clock frequency f, and from this f we can calculate the period f is equal to 1 upon t, or t is equal to 1 upon f. Hence we get here t is equal to 1 upon f is equal to 1 upon 1 into 10 raised to 6. Here 10 raised to 6 stands for this megahertz. That means here we obtain the frequency 1 into 10 raised to 6 hertz. Here 10 raised to 6 means mega. Okay. By solving this, we get the clock period as 1 microsecond. Okay. I hope you all understand the calculations. Then after finding the clock period, the next step is, now for the given time delay, find the total number of clocks. Okay. After finding the clock period, then we have to find the total number of clocks. For example, find the clock pulses to produce delay of 4.096 millisecond. Assume that the clock frequency of 12 megahertz. We already seen that for 12 megahertz clock frequency, the clock period is 1 microsecond. Here we calculated the clock period for the 12 megahertz crystal, and which is 1 microsecond. Okay, hence we write directly here, for 12 megahertz clock frequency the clock period is 1 microsecond. Then the counter will count up for every 1 microsecond. Hence the total number of clocks is given by 4.096 millisecond divided by 1 microsecond. After simplifying this, we get 4096 clocks. How we simplify this? Let's see once again. Here is 4.096 millisecond. That means 4.096 into 10 raised to minus 3 upon 1 microsecond means 1 into 10 raised to minus 6. We get here 4.096 into 10 raised to 3. Then after multiplication of this we get 4096 clock pulses. Okay, I hope you all understand these calculations. Now the next step is load the values in TH and TL registers. First of all, find the clock pulses to produce the delay of 4.096 millisecond. Assume that the clock frequency of 12 MHz. This is the previous seen example. Here is some additional part given. Load the values in TH and TL for above delay. Okay. The number of clock pulses are 4096. Here we calculated the number of clock pulses. Okay. Here we calculated the number of clock pulses. This example is similar to this example. Okay. The clock pulses are 4096. Now subtract these clock pulses from total number of clock pulses. We know that the any timer has its maximum value f. That means in decimal the value is 65,536. Okay, this is the maximum value of the clock. Then subtract this value from the maximum value, that is 65,536 minus 4096. We get the subtraction 61440, that means 61,440 in decimal. Then we have to convert this decimal number into the hexadecimal number, and its equivalent hexadecimal is F000H. Okay, here we get the number F000H. That means this 00 is of low bit, hence it's stored in TL. F0 is higher byte, hence it's stored in TH. The values of TH is F0H and value of TL is 00H. I hope you all now understand how to find the values of TH and TL. Okay, now let's see the program. Assuming that the XTAL equal to 11.0592 MHz, write a program to generate a square wave of 2 kHz frequency on pin P2.2. Okay, that means here the crystal frequency is given, which is 11.0592 MHz, and we have to write a program to generate a square wave of 2 kHz frequency on pin P2.2. Okay, we have to generate a square wave on a pin of this pin is P2.2. Okay, then let's see the solution. The period of the square wave, that means here the frequency is given 2 kilohertz and here f is given 2 kilohertz. From this frequency we can obtain the period as 1 upon f, that means 1 upon 2 kilohertz. Okay, 1 upon 2 kilohertz is equal to 500 microsecond. I hope you all know these calculations. Okay, now let us consider that the duty cycle of the square wave is 50%. Hence the square wave will be high for 250 microsecond and low for 250 microsecond. Okay, that means here the square wave is of on time and off time. Okay, this is the square wave in which this is off time and this is the on time. That means we can also say that this is the high value and this is the low value. We have to generate a frequency of a square wave of period 500 microsecond. If we consider the 50% duty cycle, then we have to divide 500 by 2. We get 250. That means we have the off time 250 and on time 250. Okay, I hope you all understand this calculation. Now the XTAL equal to 11.0592 megahertz, that is the clock period is 1.085 microsecond. We have already learned that. Hence we have to find the total clock pulses. The total clock pulses can be found by 250 microsecond divided by 1.085 microsecond. This calculation gives us 230 clock pulses. We get here clock pulses 230. Now we have to subtract these clock pulses from the maximum value, that means from f minus 230. But the problem is that this 230 is decimal and f is hexadecimal. So we have to convert this f into the decimal. Its equivalent decimal is 65,536 minus 230. We get the value 65,076. Okay, and if we convert this 65,076 into hexadecimal, then we get FF1A. Here FF is having higher value, hence TH is equal to FFH. 1A has the lower value, hence TL equal to 1AH. Okay, I hope you all understand these calculations. Now let's see the actual program. In this program, first of all, clear the basic things, that we have to generate a square wave of 2 kHz frequency on pin P2.2. Hence, for that purpose, we have the values TH equal to FFH and TL equal to 1AH. Okay. Now, this is the assembly language program in which the first instruction is move tmode, #10h. By loading 10h into tmode register, we can get the timer 1 in mode 1. Okay. Then label L1 move TL1, #1ah. That means load TL, and we calculated the values of TL as 1AH. We have to load TH with FFH. Hence the next instruction is move TH1, #0FFH. That means load TH. Then our steps are, first one is load the tmode register, then the load the values in TL and TH. The next step is start the timer. For that purpose we use the instruction setb tr1, that means start the timer. Okay, the next state is L2 JNB TF1 L2, that means remain until the timer rolls over. This instruction means that jump if not set TF1 not set to L2. Okay, if TF1 sets, that means timer overflows, then stop the timer. For that purpose we use the here instruction CLR TR1. This clears the TR1 flag, that means timer run bit now becomes 0 and the timer stops. Then CPL P2.2. CPL means complement P2.2. P2.2 has the value 0, then after this instruction it has the value 1. Okay, the next is CLR TF1. Here the timer flag sets, hence for Next cycle we have to clear it, hence we use the instruction CLR TF1. Then after clearing it, again go to the next value SJMP L1, that means jump to or short jump to the label L1, and the next execution proceeds. I hope you all understand the simple programs here. Okay, thank you.